Hello everyone. Today I'm going to talk about explainable AI in medical field. Today's presentation I will go through three questions. First of all, will robots replace doctors? Next, I will continue by what is the barrier to apply AI in medicine? And the last, I how can we trust the model? Whether robots will replace doctors is the first question I would like to figure out when I enter medical school. Artificial intelligence is such a catchword that any other specialization accompanying it seems to be powerful. Medicine and artificial intelligence are complementary to each other. In hospitals, doctors have to do quick decisions for some urgent condition. Artificial intelligence can lend a hand to filtering out unimportant data, and thus physicians can focus on vital data and reduce the error rate. On the other hand, when a patient walks into the hospital, their body produces a mass of data. Hospitals acquire highly mapped data as a resource for models to train. With more data, it is much easier for engineers to train the model with high accuracy. What's more, artificial intelligence can act as a caregiver. He or she can remind the patients to take medicine and confirm the patient's health conditions. It's also useful to tackle some trivial issues in hospitals, such as answering the questions about where to receive medicine. By using a wearable device, patients can keep track of their health conditions. Artificial intelligence plays a role in giving immediate response and warning the patient if there is something irregular in his or her health data. It is efficient to use AI to find the disease in the early stage. Cooperating with well-trained models, physicians can do the better diagnosis and therefore produce high-quality data. It seems like a good collaboration to produce data for models and provide models for hospitals. For me, instead of replacing doctors, I think artificial intelligence can improve the quality of healthcare and reduce the physician's workload. Medicine and artificial intelligence is more comrade rather than an enemy. However, although many excellent models are using medical data that have been proposed in many papers, few of them are applied in the real medical world. Most of them are still in trial or be used in highly controlled stages. Another question that's come to my mind is what is the barrier to apply AI in medicine? After I tried to build a model by myself to predict the medical data, there is a stunning fact for me. To improve the model, all I need to do is modify hyperparameters. Moreover, which parameters I need to modify or what I should modify them is still vague and without a clear explanation. The process is in a black box, or we can say, in a state of chaos. I can't explain why the model predicts in such a way to others. I can only speculate on the model prediction from my point of view, and I even do not know where might the next errors take place. Relying on a device whose logic is opaque violates the principle of medical ethics. Blackbox medicine does not enable clinicians to view the quality of training labels or data, which is contrary to evidence-based medicine. Patients' autonomy and informed consent may be harmed if they are unable to question the AI system. The potential for bias may also violate principles of beneficence. For example, an AI algorithm meant to track age level of illness on the basis of healthcare costs was found to be biased against Black patients. Algorithms that learn using past data could prolong structural inequality, which violate both moral and legal norms. And in addition to above, potentially catastrophic errors that caused by flawed models or our decision based on them is our most worried issue. As Hippocrates, father of medicine, had said, as to disease, make habits of two things, to help or at least to do no harm. If we can't be certain that the model will not harm patients, we shouldn't make a rash decision to apply it in the medical field. Every decision is about life, the most precious thing for everyone. Hence, there comes out the third question: why should I trust the models? Or is there any other way to reduce the risks? That is what I want to share today. Explainable AI. Explainable AI is a new research topic in recent years. Although the techniques are not mature now, they shed some light on enhancing the transparency of the model. Explainable AI deals with the implementation of transparency and traceability of statistical black box machine learning methods, particularly deep learning. First of all, explainable AI can help physicians explain the model into patient-translated knowledge, which is too complex for patients themselves to understand and act on. With more information, patients can understand disease better and therefore do the proper decision for themselves by model's prediction. Continue on. Physicians are unlikely to put their judgment aside in favor of a machine. They expect AI to enhance rather than replace their capabilities. The black box has been a big hurdle to trust. However, with explainable AI, physicians can interact with the model well and find out the flaw of the model. They can correct them to get a better prediction, or if the mistake is hard to avoid, physicians can be more cautious in such conditions. Furthermore, since model can add more data than humans in a short period of time, it helps to shed some light on causality and give physicians hints on where to do the further research. Let's take a look at a real-world example to understand the XAI more concretely. On the left-hand side, there is a normal brain, and on the right-hand side shows the brain MRI of patients with Alzheimer's disease. Alzheimer's disease is a more and more important disease in aging society, but we will only focus on the structure of brain today. The feature of Alzheimer's brain MRI is obvious: ventricular enlargement and cortical thinning. After building the model to classify the severity of Alzheimer's disease, we would like to confirm that the model catches the correct features. With expandable AI, we can see the clear explanation about where its model focuses on. In this picture, the model predicts by ventricular enlargement and lower side cortical thinning. Thus, we can surely approve the model prediction. What we talk above is our big dream about explainable AI, and I try to use XAI. Although there are lots of technical issues unresolved, such as unstable explanation and unwanted superpixel in the background, in our very beginning of developing explainable AI, the priority is to increase explainability and make model easier for end user to comprehend. It facilitates reasonable data-driven medicine decisions and advanced evidence-based medicine as our first step to complete usage of artificial intelligence in the medical field. Constructing an expandable AI system is a bridge for humans to realize what is the model concerned about. But our true hope still is to open the black box of artificial intelligence and not just mimic how the model works. Exploring explainable AI can give us more hints about how AI works, and we hope in the future we can know how to modify AI well to give trustworthy results and help physicians provide meticulous healthcare for every patient. Thanks for listening.